First, guys, usually we explain in English using the English language, but of course, if you have any problem in understanding any of the concepts or any questions, you may ask it through email, or if it's urgent, you may use WhatsApp to ask it. Also, guys, we will be having on weekly basis meeting through the Zoom app. It will be like office hours in which you can ask your questions, and I'm gonna be sending you the details about it through email, and I will post it also on Classroom. Now our course is named as Probability and Statistics. So trivially, it will be divided into two parts. The first part of it is about probability, in which we're going to be discussing the counting techniques and the probability theory. And most of you took these concepts in either back one or in back two. The second part of it is a little bit new for most of you, and it's about statistics. Later, we're going to discuss it in details. So mainly, we're going to be discussing in this course the counting theory. We're going to talk about the probability theory. We will introduce random variables, and mainly continuous random variables, and we're going to be using integration for continuous random variables. Then we're going to talk about discrete distribution, mainly binomial and Poisson distribution. Finally, we're going to talk about continuous distribution, or we name it as, and mainly the normal distribution. Okay, guys. This, by the way, guys, the textbook, already I posted it on our classroom, so you may just download it, and we will be explaining from it, solving some exercises from it, and if you want to practice, you may solve other exercises. And the solution of the odd exercises, they are set at the end of the book. Let's guys explain what do we mean by random experiment. When we say random experiment, if you still remember when we were kids, and most of us are still playing it till now, we play with the coin, whether it's tail or head. So what are the possible outcomes that we may get? Are head or tail? We may get two possible outcomes. Or if you still remember, usually we play with the die. The die, it has how many faces? It has 6 faces. They are numbered from 1 till 6. So these are, we name them as random experiment. The exact outcome, we cannot expect it. It means that when we toss a coin, we cannot say that we're gonna get a head. We can say that we may get a head, or we may get a tail, but we cannot be sure that we're going to get a head. Similarly, if we are throwing a die, we cannot say that we're going to get the face 6, but we may just say that we may get the face 6 or face 1 or face 2 and so on. So now we can talk about the outcomes. The set of all possible outcomes, if we are tossing a coin, it will be 2, which is head and tail. Now, if we are throwing a die, then the set of all possible outcomes, it will be from 1 till 6, and this set as, we name it as the sample space. And the number of elements in it is 6. What if we are tossing a coin twice? We may get in the first time head and in the second time head, or we may get in the first time head and in the second time tail, or we may get tail in the first time and head in the second time, or we may get in both tossing, we may get 2 tails. So our sample space now is HH, HT, TH, TT. So the number of elements is how much, guys? It's 4. Or we can write it through this tree diagram. Okay, guys, what if we are throwing a die twice? We may get in the first time 1 and in the second time 1, or in the first time 1 and in the second time 2, and so on. So the number of elements here, it will gonna be 36. Okay, guys, sometimes we cannot know the number of elements in the sample space 1 if we are tossing a coin until a head appears. So if a head appears, we stop. What if a tail appears? We're gonna throw it again. We may get either head or tail. If we got a head, we stop. But if we got a tail, we're gonna continue. And we're gonna keep in this way. So the number of elements here, we cannot specify it. Also, if we want to choose a real number randomly from the interval 0, 1, can we predict the number of elements in the sample space as? Of course not. Similarly, if we're talking about the waiting time, so guys, we can specify or classify the sample space as discrete and continuous. The discrete sample space, it means that we can count its element. For example, if we are throwing a die, the sample space, the size of it is 6, so it's a discrete one. If we are tossing the coin twice, so the sample space, the cardinality of it, or the size of it is 4, so it's what? It's discrete. Similarly, if we are throwing the die twice, the sample space, the number of outcomes or all possible outcomes in it is 36, so it will be discrete. Now, continuous, 0, 1, we name it as continuous. Why? Because we cannot count the elements in it. Similarly, the time, the waiting time, and if we are throwing a coin till we get the head, also we cannot find the number of all outcomes. So we name it as continuous. Okay, guys, now we're going to define an event. All of us know what do we mean by sample space, right? Now, an event is a subset of the sample space we are seeing. So this is the sample space. A is inside the sample space. Now, when we say A is inside the sample space, we can define the complement of it, which is outside A and inside the sample space. We can write it as AC, A prime, or we can write it A bar. A bar, it means that we're going to write it in this way. Usually, in my course notes, I write it as A bar, but in the exam, we may bring it as A prime or AC also. Complement, guys, we can give an example. If we are saying the set A is all real numbers such that x squared equal 1, the complement of it, it will be all real numbers such that x squared is not equal to 1. Okay, guys, here we're going to give some examples on event. If S is the sample space, if we say that A is an even number, what are the even numbers here? By the way, guys, even numbers are of the form 0, plus or minus 2, plus or minus 4, plus or minus 6, and so on. So we need a subset of S such that A is an even number, so 2, 4, and 6. And B, the event such that it's an odd number, so it will be 1, 3, 5. And if we want D to be greater than 4, it will be 5, 6, the event 5, 6. Now, if we look at A and B, they are what? Complement of each other. Also, when we say the union, it means that it either belongs to A, or belongs to D, or belongs to both of them. And when we say intersection, it means that it belongs to the first one and belongs to the second one. Now, guys, we're going to define what do we mean by disjoint events. So for two events to be disjoint, it means that their intersection is what? Is 1. Let's go back to the event A, which was the even numbers, and the event B, which was what, guys? Which was the odd numbers. Do we have any intersection between them? Let's check. Here we have 2. Do we have here 2? No. Here we have 6. Do we have here 6? Also no. Here we have 4. Here we do not have 4. So the intersection is 5. What do we name it? Disjoint events. Guys, again, as we said before, we did not explain, we did not go through our first lecture yet. It's just an intro to make sure that we know what do we mean by sample space, What do we mean by discrete sample space and continuous sample space? Again, discrete sample space, it means that the number of all possible outcomes, we are able to count it. Continuous, it means that we are not able to count them, and we gave some examples. We talked about the complement of an event, and an event is subset of the sample space. We talked about the intersection, and we said that when the intersection is phi, it means that the two events are disjoint. We talked also about the hopefully in the next lecture, which will going to be posted on Thursday, we're going to be explaining the counting techniques. We're going to talk about the multiplicative rule, we're going to talk about the additive rule, and we're going to solve plenty of exercises. From now till we meet on Thursday, please, all of you, stay safe. And if you have any problem, whether it's academic or non-academic, please do not hesitate to contact through email, and of course, if it's urgent, through WhatsApp. Have a nice day, guys, and take care of yourselves.